This video is on section 10.3 notes, the hyperbola. So the definition of a hyperbola is the set of points in a plane such that the difference between the distances from two fixed points, called foci, is constant. So that means if you pick a point, like this point right here, and you find this distance, and you find this distance and subtract them, so the difference between the distances, so find the two distances and subtract them, you'll get a number. And then you could go to the same curve of the hyperbola, or you could go to the other curve. And so if I were to take this curve right here and find this distance and find that distance and subtract those, the two differences, the two numbers I got when I subtracted, they'd be the same. So that's the definition of a hyperbola. None of us are going to draw a hyperbola that way. That's just the definition of how it was created. So for us, we're going to look at it this way, and it's a little bit weird to create, but once you do it a few times, it gets a little bit easier. So essentially what we're doing is kind of like an inverted ellipse. So we're still going to be able to look at the center. We're going to be able to find the center the same way. And then we'll be able to see the number underneath and take the square root of that and go left and right that amount. Take the number underneath this and go up and down that amount. But instead of drawing a circle using the numbers that we would like if we had the ellipse, we're going to draw a rectangle. And this is called the fundamental rectangle. And through the corners of the rectangle, you're going to draw asymptotes. And what happens is the curves of the hyperbola are on the outside of those asymptotes. And we have two versions. We have that the hyperbola can be the curves on the left and the right side, and that the curves can be on the top and the bottom side. And it depends on how the hyperbola is written. If the x squared comes first, x squared minus y squared, then it's the left and right side. If the y squared comes first, y squared minus x squared, then it's the top and bottom curves. So it's kind of got an interesting way of being drawn, but it's the same every time. So we'll be able to work with it. So just like we had with the ellipse, we have kind of the main number here is the vertices, but in this case, it doesn't matter how big they are. It doesn't matter that it's the biggest number or the smallest number, but it's the one that we're going to be focusing on. It's the one that comes first. So the vertices correspond with the sides that we're working with. The co-vertices are actually not even on the graph. They help us draw that fundamental rectangle, but other than that, they don't help us at all. They're not actually on the curve. And then we have the asymptotes, and we'll actually be able to write the equations for those. So we have two other vocabulary terms here that we're going to write in here and label. And the textbook had a couple example problems with these, but then didn't have any problems at the end of the section to practice these. So you may not see these again, to be honest. The transverse axis is the line between the vertices. So if we look at the line that connects one vertex to the other, this right here is the transverse axis. And then this right here is the transverse axis. And then we have the conjugate axis, and this is the axis of symmetry that's between the two curves. So on this one, the conjugate axis is right here, and on this one, the conjugate axis is right here. And I'm going to have us label those in our formula sheets on here, so that if we do have problems that work with them, we'll know what they're talking about. So the line between the two vertices, just going to draw an arrow right here. This is the transverse axis, and then this line right here is the conjugate axis, and then on this picture they are swapped. Okay, so we're going to go ahead and try the first example. It says find the center, vertices, co-vertices, foci, and asymptotes. So the center is 2, -3. And because the x goes first, that means that we're going to have the curves on the left and the right side. So 2, -3 is the center. And then we can find the vertices. The vertices will go left and right. The co-vertices will go up and down. So the vertices will go left and right 4. 1, 2, 3, 4. 1, 2, 3, 4. The co-vertices will go up and down 2. So left 4 and right 4, down 2, and up 2. Okay, vertices and co-vertices. Now, if this was an ellipse, we would just, draw our ellipse shape, but it's not. So we're going to draw straight lines that connect to make a rectangle. So this is not actually part of the curve. This is just what helps guide us to the curve. And then the lines that would go through the corners are what is going to be the asymptotes. So I can kind of see already kind of what the slope of my asymptote is. Just drawing some extra dots to make it a little easier for myself to draw. So I can see that it has a slope of down 1, right 2, and I can just tell that because of the shape of my rectangle. But we are going to do that by hand in a second so you guys can see where that came from. So I'm going to draw dotted lines for these asymptotes. Okay, now the co-vertices up and down, these don't have any purpose anymore. They were just helping us draw that rectangle. But the vertices, those are helpful. I'm going to start there, and then I'm going to follow the rectangle and follow the asymptote. So there's my curve, and then there's the rest of the curve. And here's the other one. And so this is the hyperbola. And technically, I could go back and erase the asymptotes and erase that fundamental rectangle, but I don't need to. It's fine. Everybody kind of leaves it there. So I've got my vertices, my co-vertices. I've got the asymptotes drawn. I'm going to go ahead and find the foci. So here you can remember this by the hyperbolas have a subtraction sign in the middle, and so to find the c² value we have a plus instead. So it's the opposite of ellipses. Ellipses had pluses in the equation but then had a minus to find c. So c² is going to be 16 and 4 added together, so c² is 20, and so c is the square root of 20. And we can reduce that radical. That's the square root of 4 times the square root of 5. So that's 2 square root 5. And the foci is in line with the vertices. So since the vertices go left and right, the foci are also going to go left and right. And they're going left and right this amount from the center. So we're going to go to left 2 root 5. And then to right 2 root 5. Okay. All right. Now for the asymptotes. The formula looks a little bit confusing, but they're actually pretty simple to write. Y minus k is just the parentheses that go with the y. So it's the parentheses that go with the y. X minus h is just the parentheses that go with the x. B over a is just the number underneath y and then the number underneath x, and that's your rise over run. So you have the part that corresponds with y, that's your rise. The part that corresponds with x, that's your run. Okay, so our asymptotes are going to be the y parenthesis, so y plus 3, and then plus minus, and then the x plus minus, I forgot to put the numbers in there. And then the square root of each of these numbers. So this would be 2 over 4. 2 over 4, and then the x parentheses, x minus 2. And so what we have is, I'm going to write down the two asymptotes we have. We've got y plus 3 equals positive 1/2 x minus 2, and y plus 3 equals negative 1/2 x minus 2. And this is a valid equation of a straight line. These are in point slope form. It's not y equals mx plus b. It's not what we've been writing probably our entire math career, but it's a valid way to write the equation of a straight line. It is probably not what my math lab wants if you're doing a problem where my math lab asks you for this. So if my math lab asks you for the asymptote, the equation of the asymptote, you're going to have to look and see if they want a specific format for it. But if they don't, this is sufficient. So if I want to check and make sure this is correct, I'm going to look at the point, and the point is 2, negative 3. I'm just doing opposite sign, opposite sign. So 2, negative 3 is right here. And then to check my asymptotes, I'm just making sure that they have the correct slopes. So one of them had a slope of positive 1/2 from that point. So up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2. And so that represents this line right here. And then the other one starts at the same point, positive 2, negative 3, and it has a slope of negative 1/2. So down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2, and that's the other line. Of course, if you do have to write it as y equals mx plus b, and that's my guess that my math lab is probably going to ask you for that, then all you need to do is distribute your slope and move this number over to the other side. So it's pretty close to that format, but for me, for a test or a quiz, for me, this is totally sufficient, this point slope form. Okay, moving on to the next question. Find the center, the vertices, the covertices, the asymptotes. So we're going to go ahead and start with the center. Positive 2, because this is the x, positive 2, negative 1. So we're going to have to be careful when we look at these to notice which value is coming first, if it's an x value or a y value, to make sure we don't get them mixed up. And so since the y value is going first, this one has the two pieces going up and down, and that means that's where the vertices are. They're going to be up and down from the center. So vertices, covertices. Okay, so 2, negative 1. We're going to go up and down 2 from the center. And that's where the vertices are. So up and down 2, down 2, up 2. Okay, and then we're going to go left and right 3. 1, 2, 3. 1, 2, 3. So the covertices are left 3. And right 3. So when I go up and down, I'm just adding or subtracting that number to the y coordinate. When I go left and right, I'm adding or subtracting that number with the x coordinate. So now I'm going to go ahead and make my rectangle. And with this one, I can see that my slope is that it's going down 2 over 3, down 2 over 3, down to over 3, 2, 3, 2, 3, 2, 3. And then got that same slope again, so 2, 3, 3. And this one, the y comes first. We said we're doing the curves up and down, and so I'm going to start at the vertex and just follow the rectangle and follow the asymptote. Nope, that one didn't. I didn't draw that very well. But there we go. There's our hyperbola. Okay, so we have center vertices, co-vertices. We're going to find the foci. So c squared is 4 plus 9. So c squared is 13, which means that c is the square root of 13. And the foci is in line with the vertices, which went up and down. So I'm going to go up and down root 13 from that y coordinate. So 2, -1 minus root 13, 2, -1 plus root 13. All right, for the asymptotes, I'm going to do the y parenthesis equals the square root of this number divided by the square root of that number, so plus minus 2 over 3, and then the x parentheses. So for our two asymptotes, we have y plus 1 equals positive 2/3 x minus 2, y plus 1 equals negative 2/3 x minus 2, and we can check it and make sure it makes sense. We have the point 2, -1, so 2, -1 is right here, and for one of the asymptotes we go up 2 over 3, up 2 over 3, up 2 over 3, so that's this asymptote. For the other one, we're going to start at 2, -1, we're going to go down 2 over 3, down 2 over 3, and that's the other asymptote. And again, if you needed to write this in y equals mx plus b form, you would just take the slope, distribute to get inside of these parentheses, and then subtract the 1 over. All right. So for these other types of problems, they're going to ask you to take some information and write the equation of the hyperbola. And so I put little graphs on here so that we could sketch them and so that we could get like a more accurate sketch to maybe make this a little bit easier for ourselves. So kind of similar to the other problems that we've been working on, we need to figure out from the information they gave us which equation we're looking at. Is this one of the curves where it's the top and the bottom, or is this one of the curves where it's the left and the right? And then we have to figure out where the center is and figure out how wide that rectangle is for the left and the right, how tall that rectangle is from the top and the bottom, so we can figure out what numbers should be in the bottom of our fractions. So this one starts off with those vocabulary terms. It says find the equation of a hyperbola whose transverse axis. So just a reminder, the transverse axis is the axis that connects the two vertices together. So we know that whatever information they give us, it's going to be the line that goes between the two vertices, and that's important because that's where the actual curves are. So the transverse axis has endpoints of 0 and then positive and -4. So 0, 4, 0, -4, that's the transverse axis. So these are the vertices, which means that the hyperbola looks like this. And I don't care if this is accurate or not, because I just need to make sure that I know that these go up and down. So now I know that this is a y² minus x² equation, And I also feel pretty good about having the center at 0, 0. But we can continue. It says the conjugate axis has endpoints at positive and negative 2, 0. So 2 and 2. So we could draw our little rectangle if we wanted, because it gave us the endpoints of each of those axes. Okay, so we're going to start with the y. And then we have x. That shouldn't have been h. Sorry about that. That should be k. Y minus k squared, x minus h squared. And this should equal 1. Now, because this is centered at 0, 0, we know that the h and the k are going to be 0. And then here we have, from the center, it goes left and right 2, and 2 squared is 4. And then from the center, it goes up and down 4, and we know that 4 squared is 16. So the equation of the hyperbola is y squared over 16 minus x squared over 4. Okay, let's try the next one. Find the equation of a hyperbola with asymptotes. Y is plus or minus 2. So y equals positive 2, so 0, and then up 2 over 1, up 2 over 1, up 2 over 1. So I'm just drawing the asymptote. With that slope, okay? And then we have y equals negative 2x, so we'll start at 0 and then go down 2 over 1. And so we learned a couple things with this, but we learned one thing very, very specific with this, and that's that the center of this graph is at 0. So if you look back at the previous examples we did, those asymptotes cross at the center. The asymptotes cross at the center. So that means that we now know the center of this hyperbola. So the center is at 0, 0. Okay, and then they also tell us that the x-intercepts are positive and negative 3. So we're going to go 1, 2, 3, there's negative 3. 1, 2, 3, there's positive 3. And so here, this tells us something else. What it tells us is that the curves are on the left and the right side because x-intercepts are actual points that are on the graph. They wouldn't give us a point that does not show up on the graph. So that means that we're starting our equation with an x. So x minus h and y minus k. So that's important. And then it also tells us, since these are directly to the left and directly to the right of the center, we also know how far left and right it went from the center because the x-intercepts are in line with the center. So we know that 3 squared is 9, so we know this number right here has to be a 9. All right, so the next trick of this is to remember where the asymptote comes from. The asymptote comes from y minus k, that set of parentheses, and then it comes from the square root of the number underneath here. So this number is b squared, so it comes from b over a, which is 3. 3 squared is 9, and then x minus h. This is where the asymptote comes from. So somehow b over 3 simplified to become a 2. And it was plus or minus. I can write that in there. Plus or minus. Plus or minus b over 3 simplified to become plus or minus a slope of 2. So b over 3 is 2. So if I want to figure out what the b value is, I just need to solve for b here. I can multiply the 3 over, and b equals 6. So I'm going to go ahead. 6 squared is 36, and so that's the number that goes here. Now, I would recommend always doing the problems that way because this is a pretty quick way to do it. But if you were struggling, you could also just, if you've drawn this perfectly on a very nice grid, you could also just take this line and draw it up and see where it runs into the asymptote. So what I'm doing right here is I'm creating that rectangle. I can see where it runs into the asymptote. It runs into it right here. And then when I create my rectangle, I can say, oh, it's crossing right here, and this is 6 spaces from the center. And so 6 squared is 36. So that's another option. It just takes a little bit more time, and you have to draw it perfectly. Okay, let's try this next one. It says find the equation of a hyperbola, and it has foci at positive and negative 5, 0, positive and negative 5. So here's a focus. Here's a focus. Okay. And then it has y-intercepts at positive and negative 4. Okay. So this tells us, since the y-intercepts are there and the foci are there, it tells us where the vertices are. It tells us this is a graph where the curves go up and down. So we know that this is what we're dealing with. Now I can also tell that the center of the graph should be right here in between those points, halfway in between those points, and it should be in a straight line with the vertices and the foci. So I can tell that the center is at 0, 0. So I'm going to go ahead and start writing my equation. I have y minus k squared, x minus h squared. And I already know that the k and the h are zeros. Both of these are zeros. And I can tell 1, 2, 3, 4, I can tell that this is 16. 4 squared is 16. So now I'm going to go ahead and use that formula that I have that helps me find my c. C squared is the numbers underneath added together. So this is my a squared currently. It's the number I don't know. So c squared equals a squared plus b squared. So we have c squared, the c value is 5, that's from the center to the focus, so that's 5, so 5 squared is 25, equals 16 plus a squared. And so if I subtract the 16 over, I get that the a squared is 9. And so that means that this right here would be 9. So the equation that I have for my hyperbola is y squared over 16 minus x squared over 9 equals 1. All right, next, we are going to convert the equation of a hyperbola from the general conic form into the standard form of a hyperbola. And so in your my math lab assignment and in your textbook, it will give you these different problems where they're written in this general form, and you have to recognize which of the 4 conic sections it is. Is it a parabola, an ellipse, a circle, or a hyperbola? And you can always tell when one of these is a hyperbola because when you look at the squared terms, one of them will be negative. And that's because this is the only equation that has a negative in it. So when I look at this one, I can see the x squared term is negative. That means automatically that I'm working with a hyperbola. And when I look at this and compare it with my formulas, I can tell that since the x squared is negative, we're going to be working with this formula. The y parenthesis is going to come first, the x parenthesis is going to come second. So when I set this up to do my completing the square process, I'm going to write all my y's first. I'm going to say 9y squared minus 108y. And then I'm going to say negative 4x squared minus 24x. And then just like I always do, I'm going to take that constant and move it to the other side. So equals positive 36. All right, now I'm going to go ahead and take out a GCF for both of these. So take out the 9. That leaves me with y squared minus 108 divided by 9 is 12. Okay, and then the GCF between these two is a -4. And that leaves me with x squared plus, the reason it's plus is because I have a negative divided by a negative, so that leaves me with a positive. And 24 divided by 4 is 6. And then there's my blank. All right, so now I'm going to complete the square for both of these. I have -12 divided by 2 is -6. -6 squared is positive 36, and so that's going to be the number that completes the square. 6 divided by 2 is 3. 3 squared is 9, and so that's the number that completes the square for this one. So now that I've added numbers to the left side of the equation, I have to add the same thing on the right side of the equation to keep things balanced. So here it looks like I added a 36, but I didn't. I really added a 9 times 36. And 9 times 36 is 324. So I'm going to add 324 to the right side of the equation. Here it looks like I added a 9, but I didn't. I really did. I really added a -4 times 9. So I actually subtracted 36. So since I did that on the left side of the equal sign, I'm going to do the same thing to the right side of the equal sign. Okay, so now I have 9 and then parentheses squared minus 4 parentheses squared equals a number over here. And I can tell this number over here pretty easily because those cancel. So 324. Okay, so for my parentheses, I just look back up at what I got when I divided by 2. I got -6, and so this one is y minus 6. When I divided by 2, I got +3, so that's x plus 3. And now my goal is to make this equal 1. So I'm going to divide by 324. Divide by 324, divide by 324. All right, so that's just 1. Now these fractions should always reduce so that you have a 1 on the top, so it's just your parenthesis, and then some number on the bottom. So 9 over 324, turn that into a fraction, 1 over 36, that looks good. So I've got y minus 6 squared over 36 minus, and then 4 over 324, 1 over 81, x plus 3 squared over 81 equals 1. And so here's my hyperbola. All right, and on to the applications. It says a light ray aimed at one focus is reflected toward the other focus. This reflecting property is used in telescopes. Within the telescope, a small hyperbolic mirror with the same focus as the large parabolic mirror reflects the light to a more convenient location for viewing. So our example says the focus of the main parabolic mirror of a telephoto lens is 10 inches above the vertex. A hyperbolic mirror is placed so that its vertex is at 0, 8. If the hyperbola has the center 0, 0, and foci of 0, positive 10, 0, negative 10, then what is the equation of the hyperbola? So in the picture, this right here is the center. And so we can tell that the hyperbola, it says it has foci 0, positive 10, 0, negative 10. That's the foci. And then here's the hyperbola at 0, positive 8. There'd be, in theory, another one at 0, negative 8. And so this means that we're dealing with an equation that starts with y minus k squared, x minus h squared. And we can tell, we already know the center's at 0, 0. They gave that information to us. And then we know that from the center, the actual vertex right here is 8 spaces away from the center. So 8 squared is 64. And I'll call that a squared. And then I know that the c value is 10, a length of 10 from the center. So I know that c squared is 10 squared, or c squared is 100. So c squared is a squared plus b squared. 100 is 64 plus a squared. And so I can go ahead and subtract the 64, and I get that a squared is 36. So the equation of the hyperbola that's represented in this situation would be y squared over 64 minus x squared over 36 equals 1.